My name is Michel Salim. I'm a production engineer at Meta, and I'm here to talk about how we contribute to Linux distributions. So yeah, I've been a Fedora contributor since 2003 and a Debian maintainer since 2022. And that's my contact details if you want to reach out afterwards. So it's kind of nice to be able to work on what I'm already doing anyway as my day job. So I'm part of the Linux Userspace team. Our mission is to contribute to upstream Linux projects and then leverage the contributions that we make to apply them into our production fleet so we can use them. This talk is intended both for open source community members who might be interested in either like finding out what we do and why we do them, or like to collaborate, or people who work at companies who might want to basically contribute more to open source or convince their bosses that they should contribute more. So as a background, I want to start by covering what we actually run in production. This might set some context into why we do things the way we do. Like some other companies that operate large-scale infrastructures, we actually have our own data centers. There's a link to our public website that you can check later that actually describe how we operate our data centers, where they are, and a lot of interesting things. We have millions of servers. Most of our workload nowadays are containerized, but we have our own container management system that predates Kubernetes, so that's what we use. And we use CentOS Stream, and before that CentOS, on both our physical hosts and also on our containers. And we are currently in the process of migrating from CentOS Stream 8 to CentOS Stream 9. So why do we use CentOS Stream? It's basically, it gives us enough ABI compatibility, so we can be assured that it's a stable base to both deploy production workloads and also to do modifications on top of. It's supported for a reasonable time frame. I think CentOS Stream supported for 5 years. And it's an opened up development process compared to the previous CentOS, where we can actually suggest improvements and code fixes, and if they are in line with what Red Hat wants to do, then they can actually get merged in. We don't run stock CentOS Stream. As a large company that deploy a lot of our own technologies, we actually find the need to make changes. So we run it with updated some components like the kernel and systemd. I stole this from the CentOS Stream announcement, but this is a nice visualization of how CentOS Stream sits between Fedora and Red Hat Enterprise Linux. So basically every few Fedora releases, I think every 3 years now, so every 6 Fedora releases, it gets branched and stabilized, and then it became CentOS Stream. And then Red Hat Enterprise Linux minor releases get branched off from Stream every 6 months. We also use Fedora at Meta. It's not for running production workloads, but we tend to use it on desktop and laptop systems. Fedora tend to be released much more frequent, every 6 months, which means it tends to support the latest hardware, provided you're not using NVIDIA GPUs. If you are, then you might not want to be on the latest Fedora. So if you have been to our booth downstairs, well, if you have been to our booth next door, you'll see that we have a demo of good thing we checked the mic. That one ran out of battery. Yeah, if you have been to our booth next door, you'll see that we have this demo of Fedora Asahi Remix running on Apple's M1 hardware. And that's an example of us using Fedora because we need a machine running Linux to do ARM kernel testing. Like we have engineers that do file system work, mostly on Btrfs, but also on XFS, and we might need to be able to reproduce issues or do stress testing on platforms that we don't have in production. We do some Ubuntu work as well. This is mostly to do continuous integration. I mean, like Ubuntu is still the most popular Linux distribution out there, so if we don't test our open source projects against Ubuntu, it might break on our users that we don't know about. Also, platforms like GitHub basically default to, you get runners to do GitHub actions, but they all tend to be Ubuntu-based. So why do we contribute Upstream? I mean, like it's open source, right? We can just take the software and use it without like ever contributing back. There are multiple reasons. One is that we also author a lot of open source projects, and we want to make it easier for the community to consume what we do. And rather than waiting for community package maintainers to actually pick it up, sometimes it's faster to just like do it yourself. We have discovered bugs in the past just by packaging something in a distribution, and it gets compiled with a different compiler or a different version of a compiler, or it gets compiled on architectures we never thought to test about, like Debian supports MIPS or Fedora supports S390 mainframes. It also, internally, it's easier to basically just get our changes out there and integrate it in distributions rather than having to keep rebasing all our changes every time there's a new version. And surprise, surprise, it turns out that distributions are actually really good at building packages. And why should we try to reinvent the wheel, right? Going to distributions specifically, we contribute to Fedora because Fedora is the eventual upstream for CentOS Stream, and therefore it's an indirect upstream for all the Red Hat Enterprise Linux and rebuilds like Alma Linux or Rocky Linux. It's also because RHEL and CentOS Stream does not actually carry a lot of packages. Most large deployments will have to use this extra repository called Apple, extra packages for Enterprise Linux, and that's maintained as part of Fedora. So if you want to contribute to it, you better know how to contribute to Fedora anyway. We contribute to CentOS Stream because that's what we run in production, and we want to be able to report bug fixes, submit changes, and basically, as I said before, we want to minimize the changes that we have to carry every time there's a new version we rebase on. We started contributing to Debian recently, and again, we both want to package our stuff and also like use Debian in CI. Debian being the upstream for Ubuntu and other distributions. Like once you get your package in Debian unstable, it ends up in distributions like Kali Linux or Raspbian and Ubuntu without you having to do anything else. We don't really contribute to Ubuntu directly, even though we do use it for CI. If you go to Ubuntu's contributing page, they actually do suggest that you contribute to Debian anyway before you submit a package to Ubuntu. Ubuntu imports packages from Debian continuously until they cut off their development branch to stabilize it for the next Ubuntu release. So by contributing to Debian, you end up in Ubuntu anyway. Ubuntu releases tend to be frozen unless there is a bug fix that's needed. So a lot of people, basically, if they want newer packages, they have to resort to using PPAs, which are add-on repos for Ubuntu. So let's go more specific and say, like, what are some examples of what we contribute and how do we actually work upstream? Linux distributions tend not to actually, they don't accept contributions from companies as companies. They accept contributions from individuals. So we basically, when we contribute upstream, that's meta engineers working in as individuals and like getting going through the package maintainer approval process as individuals as well. There is no special treatment. So in Fedora, we the main way to actually effect changes is through this process called change proposal. It's similar to PEP in Python and different projects have different names for a similar concept. The idea being that rather than just making the change without telling anyone, you propose it first, you have a write-up, you have a design document, and people can argue about whether it's a good change or not, and potentially like reject your change if they think it's too dangerous or it's not impactful enough or it has too many downsides. We do a lot of package maintenance, and we also contribute to the Apple repository. These are some highlights of what change proposals we got through Fedora recently. In Fedora 33, we switched the default file system for Fedora Workstation to Btrfs from the previous ext4. In 35, we changed the default file system for the cloud edition of Fedora to Btrfs as well. So right now, unless you install Fedora Server, you get Btrfs by default. In Fedora 34, we enabled systemd umd to be the out-of-memory daemon that basically, if your system is running low on resources, it picks a process to kill. And this replaced early that was the Fedora default before then. And in the upcoming Fedora 38 release that's coming out in a month maybe, we put up a change to, by default, compile every applications with frame pointers enabled, which make it much easier to profile and debug applications. Because we are just like one community contributor, right? Like we don't have automatic, like, hey, like we want to do this. Some of our change proposals don't go through. This one is like probably an infamous example. Like we proposed adding fs verity, which basically let you be able to verify like if an RPM has been changed at the time that you actually consume the content. So if you are interested in some of our open source projects on Fedora and most other Linux distributions, you can just DNF install these things. We have interactive system data tool called Below. We call it Below because it's not ATOP. Just like more is not less, less is more. We have Dragon, which is a really cool programmable debugger that you can use on Python. So you can basically you can combine like all the expressiveness of Python with when you are doing debugging. And we have systemd, which you might have seen if you went to our systemd workshop on Friday. This is a Python library to talk to systemd over dbus. So again, the idea is that you have a very expressive language that you can use. And lastly, we have Make OS Image, which let you build your own OS images really easily. Another example of what we contribute is Apple. Carl George from Red Hat had a talk yesterday about Apple 9. If you want to check out more about how Apple works, I'll just give a brief high-level overview. Basically, when Fedora gets branched to be a CentOS stream, only a subset of packages are brought in, which makes sense because CentOS stream will eventually become Red Hat Enterprise Linux, and Red Hat actually sell this to customers, and that means when something breaks, they have an obligation to actually get it fixed, right? Because your customers pay for this, and supporting the tens of thousands of packages in Fedora will be nightmarish. So basically, if you have a package that you need to use and it's not available in RHEL, you have to basically get it packaged in extra packages for Enterprise Linux. This is kind of similar to the very early Fedora days where you have Fedora Core, which is maintained by Red Hat employees, and you have Fedora Extras. With a twist. Apple right now starts off empty for every RHEL release, meaning that you might want to package something and you realize it has 5 missing dependencies, and then you go deep down and like that dependencies have more missing dependencies. And since it's not maintained by paid employees, requesting a package, you might not actually, it might take a variable length of time before someone actually like process your request. So we work with the Apple steering committee to create procedural workflow to actually make sure that we don't have package requests hanging indefinitely. We also created a tool called eBranch that basically can be used to make it easier to bring Fedora packages to Apple. There are 2 talks that I did in CentOS Dojo and CentOS Connect if you want to get more details. But I'll go and do some brief overview after this. It basically, given like a package that you need in Apple, it will show you the transitive closure of all the missing build dependencies, and it will tell you like how to actually build them with as much parallelism as possible. And for packages that you don't have ACL on, it will it will help you file Bugzilla issues, so the maintainer knows that someone needs it for Apple. That's what the tool looks like, and I'll go through some example really quickly. So you can basically say, hey, I want to package Python before in Apple 9. What are missing? And it will tell you, oh, it's missing 2 build dependencies, and these are the versions that are needed. And it's like, okay, can I want to file a request that say like, hey, this is my Fedora username, and please branch Python DKIMPY for Apple 9. And like I mentioned, you can ask like, hey, how do I build this set of dependencies together? And it will tell you, oh, DKIMPY and PetAt can be built in parallel, and after they are done, you can build Python before. So this tool has been really useful for us. Once it was in good enough shape to actually use, we use it to basically branch 686 packages last year, with over 400 packages alone branched and built in November last year. So another area we contribute directly to is CentOS Stream. And our main contribution is basically that we started and ran this special interest group for CentOS called Hyperscale. There's a link to all our talks, but these are some highlights. Davide introduced CentOS, the Hyperscale SIG in 2021. There's follow-up in Scale last year, and Anita and Dan talked about how we maintain systemd in Hyperscale. We also have Davide sitting in the CentOS board of directors. So what is Hyperscale? Hyperscale basically is focused on enabling CentOS Stream deployment on large-scale infrastructures. So we have people from Meta and Twitter in the past and Intel that are using this to build different use cases. We use Hyperscale to build packages that cannot be in CentOS Stream or in Apple for different reasons. For instance, if we want a newer version of a package, but it can't be upgraded in CentOS because it will break, like it's not fully compatible with the previous version, we can put that in Hyperscale. If we have additional functionalities that we need, like Btrfs, which is not in the Red Hat Enterprise kernel because it's not supported by Red Hat. We can basically enable it in the Hyperscale kernel. Intel maintains packages that have CPU optimizations that have not been proven to be safe enough to be just shipped in Fedora yet. And sometimes we have packages that we have additional needs that are not secret, but doesn't make sense to include upstream. Like we at Meta, we have shells like fish that we have to rebuild because we need to do additional logging because this will be running in our production systems and we want to know if what commands people are running. So there are links here to packages that we built in Hyperscale, and there are links to the tooling repos that we have for this. And last but not least, Debian. We started contributing last year, the idea being that we want to bring packages, we want to bring projects that we maintain into Debian so that they get to like a wider audience. We sometimes also need to package dependencies that these projects need. So right now, for instance, we have the Dragon debugger package in Debian, and we have Arch Linux keyring, which is not our project, but systemd macOS image needed if you want to use it to build Arch Linux images. And if you have an out-of-date keyring, it's basically like your packages won't pass signature checks. And we have an Ubuntu PPA with some of this because even for the packages that have been added to Debian, because Ubuntu only update them every 6 months, they might end up being very stale. All right. Let's move on to some lessons we learned along the way. It really helps to have multiple people working on like any of this. In Fedora right now we have 2 people who are packager sponsors, meaning that they can sponsor new contributors. And we have one proven packager. Proven packagers in Fedora basically can do what Debian call non-maintainer updates. So in case you have a mass rebuild that affects a lot of packages, you have a coordination problem if you have to basically wait for all the maintainers to do their own builds. So proven packagers can step in and say, okay, I'm just going to update and rebuild everything for you. We have 2 Meta employees who are full Debian developers, not on our team specifically, but they are on related teams, so we can basically ask them for help. And that really speed up the process if you want to onboard someone new. And we have about a dozen employees who have been contributing to Hyperscale. One thing to note is that Fedora, CentOS Stream, Debian are to a greater or lesser extent community projects. Basically, like so, when we are engaging with them as Meta employees, we have to remember that to wear our community hat. Like it helps that you have someone that like is available and is actually working, that you can actually directly hit up and say like, hey, I'm blocked on this, can you review my changes? But this is not a license to say like, hey, skip the review, just stamp my changes, and like who cares about reviewing properly? And also like, we are not trying to do this in a click. We are like, we want to help out by also reviewing changes made by non-Meta employees. Having dealt with both Fedora and Debian, like there are things that are easier to do in one than the other. I'm not saying one is better or the other. In Fedora, it tends to be easier if you need to update a package across different Fedora releases. Whereas in Debian, the workflow tends to be more you package to unstable, and you don't really touch the stable releases unless you have a strong need for it. So there is more like there's more hoops to go through if you actually need a package updated in a stable release. It's also easier to basically access the build system. Anyone who is authorized to be a Fedora packager can basically borrow the CI system and say, hey, I need to do a scratch build just to test whether whether there's a bug you want to repro or there's a fix you want to test before you commit. Debian is something similar called porter boxes, but they're only available to full Debian developers by default unless you ask for it. Conversely, there are also things that Debian does better than Fedora. By default, basically, you use DH to help maintain your Debian package, and it does a lot of magic behind the scenes. By default, it can auto-discover what test suite needs to be run and how to invoke it. And unless your package has something unique, you basically don't really have to tell it how to build your package. There are links there that you can check later to actually compare and contrast how many manual steps you need to actually tell Fedora how to build Dragon compared to how to tell Debian to build it. And sometimes, especially running tests by default, is really nice when you have weird bugs. For instance, the Dragon compile debugger depends on libkdump file. Libkdump file, it turned out, had issues on a lot of issues on architectures that are not Intel that we didn't discover because when we packaged it for Fedora, we forgot to run the test suite. There's a lot of issues to do with endianness, and there's other issues that I forgot that also affect architectures that are not Intel. Debian's also basically, in Fedora, you tend to basically say we support one version of Python, we support one version of a library, which is nice because it's a forcing function to force every you try to basically encourage Upstream to use the latest dependencies as much as possible. Sometimes though you do need to have multiple versions, right? You need multiple Python stacks, especially in Apple, because the default one is too old. Or you need to do you need to package different versions of a library because the API changes too much and you cannot just have every dependent use the latest version. Debian's packaging basically make it much easier to have different libraries installed side by side, because by default you actually have to version your binary packages. It makes some things really hard to package in Debian, but that's perhaps a good thing. It's not necessarily a bad thing. We have one project that doesn't have a stable ABI, and basically we kind of basically say, well, in Fedora we'll just bump the SO name every release because we cannot guarantee any stability, and this will make it really hellish to package in Debian, so we don't. One thing that you basically probably need to have when dealing with working upstream is that you need to have some patience. You are working with community volunteers, you are working with other XFNs, other companies and so on. And what's important for you might not be important for them, right? Distributions also have an incentive to basically not just let anyone contribute because they want people to show some commitment, right? You don't want to just show up, do something, and then just run away. So from experience, it takes months to be a Debian maintainer, which is not too bad. And Debian maintainers can basically operate mostly independently, but not always. You still need to Debian developer to sponsor every new package, or to add any new package to any new repo. It might take several years to be a full Debian developer. In Fedora, it's easier to start contributing, but if you want to make larger changes, change proposals, it does make it much easier if you have been consistently contributing for a while and people basically know you by reputation. So yeah, do contribute. Don't just like hoard all your changes. It's fun, and it's beneficial both to the community and to your own company or to yourself. Uh, Basically, at the very least, the least you can do is like if you find an issue, report it, right? Like you never know, right? Like maybe other people have also like seen that issue before, but nobody has bothered to report it, so the developer doesn't know about it. This works much better if you actually, like say you have a rel support contract and you file a bug. Um, if you are like reporting a bug to a community distribution, you might have to do a bit more work. Like it goes much better if you have a way to easily reproduce, or if you actually have a proposed fix. You basically working in the open as much as possible really helps. Um, before we start Hyperscale, we used to basically build a lot of our changes internally, and that means we have to maintain an internal build system, which is not fun, especially when we say like, hey, we want to try supporting a new architecture. It's like, oh shoot, we have to change our build system now. And the same way, like our internal build system was a bit too accessible in that any employee can use it, which we find led to the same issue that some people need a package, they build it once, and then they forget about it because they don't really care about maintaining it. And you never know, right? Like other people at other companies might have the same issue, and like you have been working independently to basically reinvent the wheel, and like, oh, 5 companies rebuilding the kernel because they want one fix that's not in the upstream kernel release. Working with the community, like basically like you just go with the flow and like get a feel of how the community works. It makes it much easier to actually when you actually need to propose changes. So yeah, that's all I have. If anyone has questions or want to go back to one of the previous slides, let me know. Thank you.
Questions, anyone? Looks like enough. Oh, here we go.
For you specifically, why were you? For yourself, what got you interested into doing an open source project and continue developing in the open source community in the long run?
So personally, I've been a Linux user for a very long time. I think since '98, which was when I have my personal computer, and I've been wanting to use Linux for about 3 years before then, but I don't have a machine to tinker with. It's basically it's like it's like when you go back to like the old days before you have transistors, like when hardware is actually like hackable. It's like if you like to tinker, if you like to know how things work, basically like working with Linux or working with open source, you can look under the hood, right? You don't just have to basically accept what the what the programmer or what the company that makes software like intend for you to use it. You can make changes, you can like learn how things work, and then it makes it easier to pick up like if you want to learn a new language, if you want to learn like how to how to do GUI development or how to do networking or something. So I think it's both like learning, helping other people learn, like basically when you if you're just doing something for a hobby, like it's probably not worth the time and expense to actually try to monetize it, right? So like just doing it in the open is much easier.
Yeah, I did not understand the difference between regular CentOS and CentOS hyperscaler. Can you explain the hyperscaler part, or is that something I can use in my environment?
Yeah. So hyperscale is actually basically just basically you can think of it as a very small repo that you can add to a normal CentOS stream deployment. It brings in some extra packages that we want to maintain this in the open. So this is like a community managed repository for things that cannot be in CentOS, right? Like say like there's an old version of Emacs in CentOS 8, and basically Red Hat cannot update it because it might break a lot of add-on packages that work unless you upgrade everything, and then like and we needed a new Emacs, so we put it in hyperscale. Or for example, like there is the major version of systemd that's shipped with CentOS Stream will probably stay the same unless there's a need to upgrade it. And if you have a feature that you need that's only in a new version of systemd, you can take systemd from hyperscale. We also have ISOs that you can download an image if you need to use, if you say like, hey, I want to use CentOS Stream, but I want to use Btrfs, and the default kernel doesn't support it, so obviously you cannot use the official installer to use it. So we have a patch kernel and we have a patch installer that let you install with Btrfs. All right, if there's no more question, thank you everyone for coming.